First question, we're going to have to find the first derivative and second derivative of this equation. To find the first derivative, we have to multiply this 4 times 1 because 1 will be here. That'd be 4. Then 4 minus 1 equals 3. So this would look like 4x to the third. Same with this one. 2 times 6 equals 12. 2 minus 1 equals 1. This would look 12x. This one, 8 times 1 equals 8. 1 minus 1 equals 0. So 0 equals 0. And then 3 to 0 equals 0. Okay. So this means that our f prime of x is going to be 4x cubed minus 12x plus 8. And then we're going to use our f prime to do our second derivative. We're going to do 4 times 3 equals 12. 3 minus 1 equals 2. 12 times 1 equals 12. 1 minus 1 equals 0. And then 0 is 0. It's going to be 12x to the second power minus 12. Now we're going to need to find our critical points. We're going to use our f prime, or first derivative, for this. 4x3 minus 12x plus 8. And we're going to want to factor out the 4. X plus 2, x minus 1. We're going to set this equal to 0. This is going to be minus 2, x equals negative 2. Then it's going to be plus 1. This is going to be x equals 1. And I forgot you have to add the square root, that squared right there. And these are going to be our critical points. Our next problem asks us to find the intervals in which f of x is increasing and when it's decreasing, as well as max, min, or neither. To do this, we're going to need to do a number line with our critical points. -2, 1. And we're going to want to test the intervals. It's going to be f prime of -3, f prime of -1, f prime of 2. So f prime of -3 is going to look like for -3 cubed minus 12, so it's -3 plus 8. This is going to be a big negative number. This is going to be a smaller positive number, and it's going to be a smaller positive number, so this is going to be negative. And then f prime of -1 equals 4, -1, 3 minus 12 to the -1 plus 8. This is going to be a small negative number. This is going to be a big positive number, and this is going to be a smaller big positive number. The smaller positive number is going to be positive. And then f prime of 2 is going to be 4 times 2 to the third power, 12 times 2 plus 8. And these are all positive. This is a positive number. And this is our negative number. Then this is going to be our positive number. And this is going to be positive, because this is going to be a bigger positive number, then this is going to be a bigger smaller number. And now we're going to want to find where intervals are, or where it's max and where it's min. To do this, we're going to have to use our f of x equation, which I believe is x4 minus 6x2 plus 8x minus 3. And we're going to plug in our critical numbers, so f of -2 and f of 1. We get -2, 4, minus 6, -2, 2, plus 8, -2, minus 3. This is going to give us 16 minus 24 minus 16 minus 3. And this is going to give us negative 27. And we're going to do our f of 1, which equals 1 full, so elevate to the fourth, 6, 1 squared plus 8, 1 minus 3 is going to give us 1 minus 6 plus 8 minus 3, which is going to equal 0. So our intervals or values will be increasing based on our number line from -2 to 1, and then 1 to positive infinity, and then decreasing from negative infinity to -2. And our minimum is going to be -2 and -27. It's going to be our min. We get this from our critical point. Our x is our critical point. And this is the value we just solved for. And then our 1 to 0, our other critical point. And then what we solved for is going to be neither. And then for the next question, we need to find all possible inflection points. And for this, we're going to use our second derivative, which is going to be 12x squared minus 12 equals 0. We're going to factor out the 12. Squared minus 1 equals 0. We're going to keep factoring. X minus 1, x plus 1 equals 0. And then we're going to set these to 0. X minus 1 equals 0. X plus 1 equals 0. Plus 1, plus 1, minus 1, minus 1. X equals 1. X equals -1. Question is asking us to find when the intervals are concave up and concave down, as well as finding which inflection points are actual inflection points. We're going to begin with the concave up and down by drawing a number line with our inflection points on it. And we're going to test intervals. F double prime of -2, F double prime of 0, F double prime of 2. We're just going to plug these into our F double prime equations. It is going to be a positive number, a bigger positive number than our smaller negative number, so it's going to be positive. F double prime of 0, 12, 0, 2, minus 12. This is going to be a neutral 0, and then this is going to be a negative. This is going to be negative. And then our F double prime of 2, which is a big positive, small, negative, positive interval. So we know our concave up is going to be from negative infinity. Oops, I wrote this wrong. There we go. Is going to be from negative infinity to -1, and then from 1 to positive infinity, and then our concave down is going to be from -1 to +1. And then we're going to do our inflection points. So we're going to use our original equation, x4 minus 6, 6x squared minus 8x minus plus 8x minus 3. And we're going to plug in our inflection points to these. 1, 4, 6, -1, 2, 8, -1, minus 3, which is going to give us 1, minus 6, minus 8 minus 3, which equals negative 16. And then f of 1, which equals 1, 4, just equals 1, plus 8, 1, minus 3. And this is going to give us 1 minus 6 plus 8 minus 3 is going to give us 0. So our inflection points are going to be -1 to -16 and 1 to 0. Okay. Now to move on to our next question. We are asked to sketch a graph of f of x given everything we've done so far, plus we have to find the y-intercepts and the x-intercepts first. So to find our y-intercepts, we're going to want to do our original equation, but replacing it with 0. So 0, 4 minus 6, 0 squared plus 8 times 0 minus 3 is going to give us -3. So our y-intercept is going to be 0 to -3. And then for our x-intercept, we are going to use this lovely factoring that we were given at the beginning. X equals 3 plus x, x minus 1, 3 equals 0. This is going to be x equals -3 and x equals 1. Okay. So now we're going to have to combine everything we've learned so far, beginning with our critical points. The critical points are our minimums is going to be -2 and -2 and then -27. -2 is going to be right here. We're gonna write min -2, -27. And then we're gonna do 1, 0, but it's not gonna mean anything or much. Right there. We're not gonna label it because it's neither a min or a max, but it's good to have. The next thing we're going to want to do is our x-intercept, which we can see is going to be -3, 0, and 1, 0. We're just going, we already have 1, 0, so this is going to be our, please. It's going to be x-intercept 1, 0, and then x-intercept -3, 0. Then we're going to want to do our inflection point, which we have right here, -1, -16, and then 1, 0. This is also going to be inflection. And -1 to -16 is going to be right around here. Inflection point. 1 to the -16. And then we have to put it all together. We know from over here that this is going to be decreasing, but we also know that this is going to be positive, so it's going to be coming from positive infinity, decreasing, passing through our x-intercept. So it's going to look like this, and we're going to want to reach our minimum right here. And because we have a minimum here, but we also know that from -1, the concavity is down, and from here that the intervals are going to be increasing, we're going to increase and go up to our inflection point. But we also know that we're going to keep going and still going to keep being concave down, so we're going to keep going. There. Our y-intercept, 0 to -3. And then we're going to want to connect those right here. And we're going to keep going because it remains concave down or concave up. And we're going to connect it to our inflection point, and we're going to keep going upward. Upward because we have concave up, and upward because we have an increasing interval. So this is what the graph should look like.